All right, science, new unit. Let's open up our textbook, or our manual. And looking ahead on page 101 in your manual. What I would like us to do, if you need to open your textbook to go with that, we are going to start learning about energy and motion. And these words are force, friction, gravity, motion, and work. What I would like for you to do is put an X in front of the column if you have never heard of the word before, or have heard, or what I think it means. This is what we are going to work on now. It gives us a little review of what we are yet to work, we're going to work on. Yes, Emma. Page 101 in your text, in your manual. You're going to fill this out. This is giving us a little review on what this unit is about. So that's what you're going to work on right now. What is force? Who has heard of force? If you have heard of it, put an X on the heard where that you have heard of it, and then what do you think it is? Bless you. All right, put your thumbs up when you are done. Who has heard of force before? A lot of you. Who would like to try and explain what force is? Owen. Yes. So if people are still writing, so I'm not going to start actually giving answers. So we're going to do a few little experiments. All right. So force, if you turn to page 126 in your textbook, a force is a push or a pull. Can an object move if it doesn't have the element of force? What do you think? If I put this golf ball on the ground and it stops, how am I going to get it to move again? Can I just will it to move? What does it need? Jack.
Force to like push it or something.
So if I, that's a force. Is that a push or a pull? Cole. Yes. Now, if I give Tyson, can you use your hand sanitizer for me, please? So what happens if I push it? Does that affect Tyson at all?
Nope.
No.
But it affects
Push
the
it.
rope.
It's a push. But what if I pull it? Oh.
It's not out of Tyson's hand.
So that is a pull. I forced his hands were instantly released from that because I pulled it. Who's ever played tug of war?
Oh, yes.
When you have two forces on each end, I'd love to demonstrate that, but we really can't.
Yeah, let's do tug of war.
But if we did tug of war, and I went on one end, and Tyson, well, we can kind of do it, Tyson. You're sanitized. Now you pull, and I will pull. So he's pulling and I'm pulling. And the ribbon is like digging into my hands. But that is, both of us are doing a force. He's forcing a pull and I'm forcing a pull. And there's a lot of force going on. All right, you can really before you cut your fingers. That hurts. I don't know how you're doing that. I was grabbing onto the carpet. So you see the difference between a push and a pull. That is force. So, what is, if you're playing a game of soccer and you're kicking the ball, is that a push or is that a pull? Owen, it is a push. It is a definite push. What is, you're on it, you see the picture on page 127. I see soccer going on. I see swinging. I see jump rope. I see a merry-go-round. Can the merry-go-round move without force?
No.
How do you get the merry-go-round to move? Do you push it or do you pull it, Grayson?
Sometimes both.
When would you pull it?
So if somebody's spinning it, you can so you're like this and then you pull it like that.
Well, that's a push. This is a pull. See the difference? Push forward, pull back.
You could pull back on a swing.
So most likely, what force would you use, Grayson? A push or a pull?
Push.
Yes. What about the jump rope? So let's say that we were just talking about tug of war. If the girls decided to play tug of war and one was on one end and the other's on the other end, what motion would that be, of force? Push or pull? Christian.
Push.
Jonathan.
Pull.
Pull. So remember tug of war, you saw Tyson and I. Tyson was doing this, and I was doing this. We're both pulling. What if you have a really stubborn donkey that doesn't want to move, and you have a rope and you're trying to get him to move? I guess you could. Would you push him?
No.
Or would you pull him with a rope? Try to pull him.
None.
Well, you wouldn't want to get behind him because then he might kick you.
Yep.
Which is another
Stomach.
force.
Donkeys are good.
So you'd try to pull him, but that's a difficult one because if he doesn't want to move, he's not going to move. What about the swing? If you're sitting on a swing and somebody gives you a what to get you going? Grant. Yes. And then you pump your legs to keep you moving. That is what? Pushing or pulling? It's kind of a tricky one. What do you think, Wensheen? Kind of. Because you go back and forth. So that's a movement as well. So, and then it looks like they're throwing a ball. If you're throwing a ball, is that a push or a pull? Olivia? Yes. Anytime it's forward, you think of forward movement, it's a push. Pulling is making something go back. What about oh, that broke. that was ineffective. That was not what I wanted. Let's try another one.
What is it? Sand?
So, I have a rubber band. What can I do to get the rubber band to move? What's one thing I could do to make it move? Luke? Pull. So what do I have to do? Pull it back?
No, that will hurt.
Woo! Way out there. So that is a pull. Kind of like a bow and arrow.
Do it again, with a bigger one.
What else can I do to get this to move? Say that louder.
Throw it. Oh.
Move forward. Is there anything else I could do to get the rubber band to move? Besides pushing and pulling. Owen. It doesn't really move though. But I mean, it does move, but stretching, but is that a push or a pull? Yeah. Cole.
Kick it.
I could kick it. Is that a push or a pull?
Pull.
Yeah, and it's not very effective.
You can put it on
It
your
doesn't go very far.
on your shoe, then yeah.
There we go. I like this one the best, the pull. What other thing do you use that you can pull back? Jack, you should know this. You pull. Pull it back. Jack. Yes. Very good. So what about friction? What is friction? Did anybody write down that they knew what friction was? Owen. Friction is a force that slows or stops. So if I have my golf ball, and I'll do that later. Will it, this carpet's not very thick. If you had a really thick carpet, like a shag carpet, would the golf ball go faster or slower than a wood floor? Wood floor is very smooth and hard. And the carpet is more what? Jonathan?
Softer.
Yeah. So there's texture. So what do you think if, I just don't think this carpet is going to be, so my friends on video probably aren't going to see this, but if I roll the ball, it rolls very easy on the hard surface. And it rolls pretty good on that. But if we had a carpet or a texture, if we put it out in the snow,
Yeah.
would it roll well in the snow?
No.
Why? Jonathan.
It's too soft and unstable.
Right. It's friction. The snow is going to act as friction and it's going to slow the ball down. Now the carpet is very smooth, so there really isn't much friction that's causing the ball to slow down. Now if I took it outside and put it in the snow, it would probably wouldn't roll at all. It would just sink and be done. Because the snow, like a heavier carpet or any kind of texture that is soft is going to be an element of friction. It's going to slow the ball down. Yes, Owen? Yes. What about, gravity. What is gravity? Grayson?
Like staying on the ground. Like not floating up.
Right. If we did not have gravity, we would be floating around. Yay! It'd be fun, but it would be really hard to do anything because we'd be floating around. What would happen if I dropped the ball? Windshield. What's that? But what if I drop it? Is it going to float? Or what is it going to do? The ball's going to float if I drop it? That was satisfying. Why does it just fall to the ground? What is that? M. Yeah. Gravity wants to keep everything in the ground. That's why we don't float, because of gravity. To get into space, if we were on the moon, we'd float around, which I think would be kind of fun as long as you're attached to something. Would not be very fun to be in space without anything attached to you, because then you would just float and float and float. So gravity prevents us from floating and makes objects fall to the ground. So if we didn't have gravity, we wouldn't have the ability to stay in place. Although floating, I think, would be kind of fun.
I would be floating.
What about something that's magnetic? What is that? Not that you have a really cool personality and you're very magnetic. Have you ever heard of that? Somebody calling you magnetic? I have a piece of wood, and I have some paper clips. Is that going to, oh, no, does that pick it up?
No, you need a magnet. Whoa.
Magical.
No,
There is a magnet on the bottom.
What's the bottom?
So, so will it pick up a plastic on the scissors?
No.
Nope. But look at that. It picks up that. Picks up the metal.
They have a ball and try to pick up.
It's not,
The board.
It's too heavy.
it's not going to pick it up. I need a bigger magnet. This is just a little tiny. But it does stick to it, doesn't it? And it does hold it. The magnet.
That's my water bottle.
Oh no, it's too heavy.
Yeah, water bottles are metal.
Wait, what?
Mine isn't.
Ooh, so, what? Okay, friends, we need to raise our hands. What causes the magnet to be doing what it does? A magnet does not have to touch an object to pull or push it. What happens if I try? Can't get it off. What is going on? Think of using a magnet to pick up a paper clip. You might hold the magnet over the paper clip. Suddenly the magnetic force pulls the magnet pulls the paper clip to the magnet. It's a magnetic force. So that's a force, like pushing and pulling. Magnetic is another form of force. If you look on page 129, so with a magnet, if I had a really big magnet, I could pick up the scissors really easy. Has anyone ever seen, I'll have to show you a video, which is very interesting. If you have, let's say you have a really old car, and you take it to the junkyard. I should show you, I'll try the video. They have a giant magnet that picks up the car and puts it in like a big trash can. That is a huge magnet. They can pick up, please raise your hand. They can pick up huge objects. So the bigger the magnet, that's like got a crane attached to it. I know what I'm thinking of. So it's a huge magnet. This is a teeny tiny magnet. I can pick up smaller objects But the bigger the magnet, the more magnetic force it has, and it can pick up bigger objects like cars and trucks.
You would like to see the video.
Should make a note. It is kind of a fun video to watch. Seeing this big giant magnet. So magnetic force is magnetism is another force that we have in our world. What about motion? What is motion? If you're in motion, are you sleeping or doing something different? What does motion mean? Sam,
Doing something different.
but what would you be doing if you were in motion? What would be an example of that?
Playing soccer?
Playing soccer. What's another example of motion? Emma. Wensheen. Just moving. Motion is moving. Yes. But what's another form of movement that you can think of that would be a form of emotion? Tyson.
When you're skiing or sledding.
That's right. Gabe.
When you play baseball?
Play baseball. Emma or M.
Volleyball?
Volleyball. Grayson.
Snowboarding?
Snowboarding. Jonathan.
Basketball?
Basketball. Wensheen. Gymnastics. M.
Tennis?
Tennis. What about napping?
No. Except if you're moving around.
You're snoring. What if you're snoring?
Yeah.
What about eating?
Yes. No. Yes. 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 Oh yeah. I like to eat.
What if you are friends? Out of my little bit. This is a big toothbrush.
Ah.
Is that motion if I'm standing in front of the bathroom sink?
Yeah.
Is there motion going on? What's the motion? Ella. Yes.
Looks like you're on her face.
Well, I'm not going to put it in my mouth. With a mask on. I'm exaggerating the motion. What about when you just took your test? You're sitting, but was there any motion going on?
Yes.
Gabe?
What are you writing?
Yes. What's moving?
Your pencil?
Yes. What is making your pencil move?
Your hand?
Is that what kind of motion is that? Is that a push or a pull? Mm.
A push?
Kind of both, really. You're pushing the pen down on the paper. Let's everybody do it. Do the motion. Your pencil is down on your paper, and you're kind of pushing and pulling. You're pulling it down. You're pushing it up. You're pushing it down. So you have both motions, or both forces going on, push and pull. What about when you're swimming? If you're thinking of swimming, think of the motion you are going through. Are you pushing or pulling or both? Grayson.
Pushing?
So you're pushing forward, then do you stop?
No.
Then you have to pull back down, correct? So you're doing both. When you're doing the front stroke, you're pushing and then you're pulling. When you're doing the back stroke, you're doing pushing and pulling. So you do both. We mentioned volleyball. You push the ball up, push, and then so it's push and pull. A lot of our motions that we do require both push and pull. What about when we ride a bike? Push or pull? Owen? Yeah. Think of something else, another movement that we use both push and pull. Tyson.
I forgot it.
Grayson.
Eating?
Eating. So you put your fork, one of my favorite pastimes is eating. So you you push the fork down and then you pull it to your mouth. Push, pull. It'd be really hard if you could only push and then your fork stays there in your yummy food and you can't get it to your mouth. That's called torture. Yeah, then you just go down and eat that. No, don't do that. So you push and you pull. What about work? That's interesting. Boy, where are you going? Okay, wait. Let me know when I thought you were leaving the room. Okay, so did you hurt yourself? Are you limping?
What?
Are you limping?
No.
Oh, okay. Work. What is work? Interesting. M. So, scientists say work is done when your force moves something. So, I am sweeping the floor. Sweep, sweep. That is work. Because I'm forcing the broom to do something. When I am, what is something else that would require work? Something else. So it's something that is done that force moves something is work. What if I kick, what if you're playing tennis and you hit the tennis ball? Is that work? Are you forcing the tennis ball to move?
Yes.
What if I am playing basketball and I'm dribbling the ball? Am I making the ball move?
Yes.
That is work. So what else? Watering. So on page hard to see the 134 in your textbook. There's all kinds of examples of work. Skydiving. You're forcing, that's what I gave both of my daughters when they graduated from high school. They got to go skydiving.
Wow, that's dangerous. Let me go.
I figure you graduate, go to college, go skydive. But they loved it. They thought it was fun. I have not done it. All right, so friends, we have all kinds of examples of work. The horse is pulling the carriage. That is work. The bicycle is moving. We're getting the bicycle to work. Shoveling snow. Working on a tractor. Who has ever seen these big giant windmills? Yes. Why is that considered work? What is being forced? What is being forced to move? M. What are these big propellers moving? Yes. Very good. So work is making something move, forcing something to move. Yes.
What is this moving?
I have no idea. It is a steps. Maybe walking up the steps. That is a ramp. So the ramp is when someone in the wheelchair goes down the ramp. Right. That's what I just said. The wheelchair goes down the ramp. So that's helping the wheelchair go down the stairs or down the ramp, because you're in a wheelchair, you can't go down the steps. So, what about the water mill? It's kind of hard to see. This picture is very dark, but who has ever seen a water wheel that spins? What is that working? Olivia. What is moving? The wheel is moving what? Yes, just like the windmill is moving wind. Wow, this went so fast. So those we did get through. So name different kinds of energy, which is on the next page. This is a vast review of everything we're going to be talking about. So if you look on page 138, that is energy. What are the kinds of energy? If you skim, there are many kinds of energy. I am on page 138 where it says kinds of energy. Sound and light are two kinds of energy. Light from the sun provides the energy needed for photosynthesis. We learned that very early on. Electrical energy is another kind. What do we use electrical energy for? Cole. To charge something. Couldn't use our phones or our tablets without electric energy. What about when we go home and it's dark? What do we flip on? Tessa. The lights. What about our appliances? If I want to make a cake and I need to use my blender, what do I need to do? I need to, something with the wall and a cord. Owen, plug it in. Can't have that without electricity. Thank goodness for electricity. Most machines use mechanical energy. Mechanical energy is energy caused by an object's motion or position. When you ride your bike, you move the pedals. This motion is mechanical energy. Coasting down a hill on a bike is also mechanical energy. You do not provide the energy. The position of the bike at the top of the hill allows you to go down the hill. So mechanical energy is energy caused by an emotion of an object. Yes. Yes. So, friends, that is a quick. Oh, what is chemical energy? Chemical energy is another energy. So what do we need to fuel our cars? What can we not have to drive our car? Jack?
Gas.
Yes. So gas is a fuel some cars burn to provide energy needed for their engines to run. What do we need? What kind of energy do we need for our bodies to run? Do we drink gasoline? What do we need to make our bodies run properly? James?
Food.
Yes. All right, this is what we're going to do. We are going to conclude our science